When we have bent and folded rock layers, it's really hard to bend a solid slab of, concrete after it firms up and dries. It's hardened, right?
Yeah.
You can't really bend it. You can fracture it or break it. And the evidence that we see within these are these folded rock layers have not undergone fracturing to get them to that shape, nor have they undergone a metamorphic process of heat and pressure, crushing it. Otherwise, you would see metamorphic changes within the folds, within the bends.
All right, what's up, guys? So we just finished our 4-day trip with Canyon Ministries. I'm here with Nate Loper, Executive Director of Canyon Ministries, and we had an awesome trip. I'm telling you guys, you need to get on a river trip with Canyon Ministries, a 4-day, 7-day. You got to book it really early in advance because everyone that goes wants to go again, and people love it.
That's right. That's absolutely right.
And I can see why now. You just got to drink a lot of water is the key. So I stuck around because I can't get enough of the canyon now. And where are we headed right now, Nate?
So Caleb, we're heading to a Red Mountain Volcano, a really interesting post-flood volcano, something that erupted after the flood in Noah's day. And we're going to be able to actually climb up inside of it because the whole front face is collapsed out of it. And it's exposed the inner workings of this volcano, the piping structure. And so beautiful hoodoos, and we're actually going to be going into the heart of a volcano, so to speak, and a fantastic, one of my favorite hikes here in northern Arizona.
Hey, that's awesome. I've never done this, so I'm actually pretty psyched about this right now. Hopefully it's not going to erupt right now, right?
Nope, no chance.
I just had to ask. So we were on what we call the lower river, right?
Correct.
In these past couple days in the rafting trip, and we actually saw a lot of evidence of lava flow in the canyon, and so that was pretty interesting seeing that. And there used to be a big dam that was formed because of the lava flows. When was that?
Yeah, so sometime after the canyon was carved, Caleb, we had multiple lava flows that erupted. Some of those lavas on the rim that actually spilled lava all the way down to the bottom of the canyon, even down to the river, and actually dammed up the river in a few different places. And then eventually those dams made inner canyon lakes for a short period of time before the water burst through there and then wiped out those dams and removed all that. But you can still see the lava and even the lava dam works, you might say, of that.
Wow. So was it multiple lava flows that we're talking about?
Yeah, multiple lava flows.
Okay.
About a dozen, we would say.
Wow. Was there one in recent history in the 1900s that happened?
No, the most recent ones would be probably about 1,000 years ago, right around there, because of some of those lava flows that actually had erupted and spilled into Native American villages, where there was actually pottery and things like that were encased by lava. So, direct evidence that these volcanoes, some of them were very recent,
Wow, that's awesome. Now, there's actually a lot of controversy on some of the dating of the lava flows. Is that right?
Correct, yeah.
Okay, now, if I understand it right, they're dating some of the lava older than some of the layers on the bottom of the canyon. Is that correct?
Correct, yeah.
Okay, what's going on there?
So in the Grand Canyon Supergroup, we do have a layer of basalt called the Cardenas basalt.
Okay.
And using rubidium to strontium radiometric dating, it actually dated as much younger than the recent lava flows on the rim of the canyon from the Uinkaret Plateau. And so it doesn't make any sense. It's the exact opposite of what we'd expect to find. The lowest layers should come back with dates that are much older than the layers up on top.
Okay.
It's the exact opposite in this case.
Wow, yeah, that seems like a big problem if you're having inconsistency right there with the layers. And so I think that ended up pushing back the dating of the canyon itself when they originally did that, right?
Yeah, perhaps, yeah.
Okay, because secular geologists are dating the canyon being carved, 5-6 million years ago, is that right?
Yeah, between 5 and 6 million years is typically what most would say. Some would even argue that it's even 70 million years in the making. It's been going on longer than even that. However, some secular geologists are even saying much more recently, if you're not talking about the Colorado River, maybe another mechanism of a lot of water, could happen much more recently and rapidly.
Yeah, I know in one of the episodes we did together, we shared a video of Dr. John Douglas talking about that exact idea, right?
Exactly, yep. Secular geologist from one of our state universities here in Arizona. And that was from the National Geographic show. And so you can actually see that not all geologists agree on how this canyon was formed or even the mechanisms by which it was formed. If the river even had much to do with it or if it was formed rapidly and catastrophically.
Yeah, that's pretty exciting to see. And I remember watching that video and it really it tied everything together for me. And I heard that a lot this week during the river tours. Everyone was saying everything is just coming together, and that was pretty exciting. And there's a lot of information we share, but I think I can confirm myself and many others who were on the trip that it really it just lights up a passion for you about how this is all pointing to the glory of God. And now I was joking earlier how I'm dreaming about rocks now.
Welcome to the club, my friend.
So I've never had dreams like that of sedimentary layers and folded rocks. Now I don't think we saw, maybe but one. I couldn't get a picture of it in time because I was fumbling around with my phone. But didn't you see one folded rock layer in the Bright Angel Shale?
Yeah, there's a folded rock layer, the Bright Angel Shale, right there by the Whitmore helipad in the canyon. So
yeah,
as we fly in with our helicopter, we can actually see a beautiful folded rock layer with multiple different colors, and it folded almost completely back on itself, actually.
That's incredible. I've seen pictures of those, and I know Dr. Andrew Snelling's done a lot of research and more that's going to come out on that. And the whole reason that matters is, was it folded when it was wet still during the flood and the flood processes, right? Or did it change because of metamorphic processes? Am I understanding that right?
Yes, yeah.
Okay.
So when we have bent and folded rock layers, it's really hard to bend a solid slab of concrete after it firms up and dries. It's hardened, right?
Yeah.
You can't really bend it. You can fracture it or break it. And the evidence that we see within these folded rock layers have not undergone fracturing to get them to that shape, nor have they undergone a metamorphic process of heat and pressure, crushing it. Otherwise, you would see metamorphic changes within the folds, within the bends. And so far, we're working on developing the evidence and showing how that looks to be, in real life, taken into samples from the park that were gathered in 2017 with Dr. Andrew Snelling and alongside with us here at Canyon Ministries, part of that trip. And taking them to laboratories around the nation and trying to put some work together. So hopefully Dr. Snelling will have the research out soon and be able to publish that. And so I'm looking forward myself to learning more about what Dr. Snelling's research shows about that.
Yeah, and we've mentioned that before in our Grand Canyon series. And I think that's going to be exciting to hear about. And of course, there's always claims like creationists are tampering with it, but he's taking it to a lab that, it's going to be completely objective, right?
Right.
Okay.
Yeah, trying to make sure that real science is done in real ways, and that there would, be kind of a bulletproof argument, you might say, hopefully, and making sure that it's done on the up and up, by scientific standards.
Yeah, no, that's going to be really huge, I think, when it comes out, and I hope everyone will check that out. An interesting conversation we had late at night during the first campsite we were at. We were talking about the side canyons in the Grand Canyon, and how that's kind of a problem for the Colorado River to carve them. Is that right?
Yeah, absolutely. We have massive side canyons, Caleb, that are very deep, cutting down through an incredible amount of layers and throughout the landscape, yet many of these side canyons are completely dry without any active water source flowing through them. And so the idea is, well, first of all, how do these side canyons get cut so deep with only maybe periodic, rainfall coming through there without an active water source slicing it? And the other side is, if the Colorado River is a continual conveyor belt removing all the sediment, then you might think that would be much deeper than these side canyons would be. But that's not the case that we typically see. These side canyons are massive in and of themselves. And so that isn't a problem with secular geology coming to understand the canyon.
Yeah.
And I can tell you that firsthand because I've been in geological gatherings with leading geologists around here, and that question has been asked, and he even said, we don't have a good answer for that. It is still a puzzle, still a mystery, So, yeah, when it comes to a slow carving, slow erosion process, or the Colorado River carving the canyon, I think there's some bigger questions that are left unanswered than we might even have with a global flood, and then post-flood carving canyon model for the Grand Canyon by massive lake spillover, a breached dam, or things like that.
Yeah, and breached dams carve out side canyons when that's what we would expect, right? I think we've even seen that in things like the Missoula flood and other things up north. Is that right?
There's side erosional features that happen from big breaches. There are backwards eddies that spiral along and help cut out some U-shaped amphitheaters. But also we have sapping features from these amphitheaters and side canyons where if you slice down through the landscape rapidly, you expose the water table. And now all the water is underneath, in layers, now starts gushing out laterally from the sides.
Oh, wow.
And the water gushing out from the sides can then cut backwards, kind of have this headway erosion, working its way backwards. And so even water gushing up pulls sediment sideways into the main canyon channel. So that's another mechanism that we see from observable flood processes even today, of basically scalloped edges. And those are basically sapping features in many cases that we see.
Now, what exactly is sapping?
So when you have like a saturated landscape, so imagine you have a whole bunch of like sand with a bunch of water. If you were to dig a little channel through that, sideways erosion is going to start to pull stuff in from the side. The water in the water table of saturation is going to start to push in towards that opening where that gap is at. And if you have a big water table, continual water starts to continually push through, and the land around it where the water is ejecting from is going to start to slump in. And it usually creates these U-shaped, amphitheaters or scalloped edges. And in some cases, if you have a nice, spring or stream coming through, there's going to continually gush water through it. And this sediment from the canyon, even when the canyon was carved, may not have been fully firmed up as solid rock like we see today. Firm enough after the flood to hold its shape, so a few hundred years after the flood. But maybe it's not even quite firm up like we see today. Maybe it's, even then easier to erode that and for stuff to come sapping out from the sides.
Yeah, well, that's I saw so many amphitheaters when we were on the raft, and we noticed that a lot. We got a lot of videos and footage of that, and besides when I was trying to not get knocked off the boat, I sat in the front, and actually I got knocked back several times. The person next to me, and that's another side thing I'd say is the rapids. I know they're more intense on the upper canyon, but they were pretty good on the lower canyon.
Yeah, Caleb, we've got some of the biggest whitewater in all of North America down
Really?
there.
Okay, I didn't know where that ranked.
Yeah, but of course our boats, are big enough to handle them, and they're rubber rafts, so they're designed to bend and flex with the waves.
Yeah.
It allows us to take anybody 8 to 88, we kind of say, is a joking way. But yeah, we have people of all ages and all skill levels.
What's the oldest person who's come on the raft?
Well, we've had people that are 88. I don't know what the oldest person was.
They might not want to say.
My oldest was 78 and did fantastic. That was on a big Upper River 7-day trip, and he did all the hikes, all the raft, and he sat near the front of the boat almost the entire trip.
Wow. It gets cold up in the front, I'll tell you that much.
It gets splash, but
yeah.
If you get a little bit too cold, you can always move to the back to the princess seat.
The princess.
You'll notice that's where I usually sit. I let you guys have all the front, all the fun seats and all the big rapids up front. So yeah.
Oh, that's awesome, man. I got this cool little river guide when I was up there. We stayed at the Barton Ranch and picked up this river guide that tells us what you'll be looking at on each mile during the river tour, and that it was really awesome. Of course, they have what we call a secular geology perspective on the carving of the canyon and the layers being carved, and so I think it's really useful to kind of compare notes with their perspective and the biblical perspective and the timeline and so on. One of the things they were talking about was just these rising and falling oceans. I think that it's like 6 or 7 times or something.
Up to 17 different times.
Oh, wow.
Yeah,
okay, that's higher than I thought.
That's a lot.
No, of course, one of the things we did see that was significant, well, several things on this river trip. Well, we saw the great unconformity, and we saw the contact lines between the layers, meaning they're pretty flat, and we don't see these massive erosional features of it that are really huge, that would show a large amount of time happening between the layers. And we've talked before about the great unconformity. That's we're saying that's when the flood started. Is that right?
Yeah, that's a worldwide erosional feature that we find where mass amounts of water started to scour the earth. And geologists pretty much all agree, when you look at things like the Tepete sandstone in the bottom of the Grand Canyon, where we find that great unconformity, geologists all agree that the Tepete sandstone was deposited or laid down by fast-moving water, and it creates a huge erosional plain. And the question is, did that form over millions to billions of years of slow, gradual erosional processes, or was that a big process happening rapidly by perhaps a lot of water?
Right.
Either a long time and a little bit of water, or a lot of water and a little bit of time, you might say.
Yeah. No, that was awesome, especially seeing that Tepete's on the top, and then we saw some rounded pebbles.
Yeah.
Right there, and we'll get the pictures up here in the video as well. In some of these books they have they mention things in here, and this is the Belknap guide But they mention all these layers, and we see it kind of like it was sheared off at the beginning of the flood. This national erosional feature right under the Tapeats sandstone. That, like you said, the Tapeats goes transcontinental, which doesn't sound like a local flood.
No, not at all.
And, it's funny, I've been studying some on the extinction of dinosaurs, and basically they're saying they went extinct by local floods all around the world. But if you just connect that, it's a global flood. But one of the things I noticed too, and I was talking with you during the week, was this this thing called Dolomite is found in a lot of these beginning layers of the flood, if you will. And what is Dolomite?
So Dolomite, Caleb, is formed by seawater typically, and it's kind of almost like a type of limestone, but you have much more magnesium added to it. So it's almost equal amounts of calcium and magnesium. And Dolomite is actually a problem for geologists to explain on how it actually is formed. There literally is in the geological, circle what they refer to as the Dolomite problem. Because we see there are mountains, like in northern Italy and places in parts of the Alps where there are huge Dolomite mountains. But the process of how Dolomite is actually formed is still to this day a mystery to most geologists. Now, look, some of the research indicates that Dolomite had to have been formed by hot water within that to cause the reactions and things necessary for that magnesium to take place as some of the calcium carbonate in there and to create Dolomite, which is a mystery to everyday geological processes, looking at how today's present processes work. How do you have super hot, ocean water, around the world? It doesn't make sense in today's processes, but if you think about a flood, the beginning of the flood, we believe the continents were breaking apart, right? That magma was being added to the oceans. We have a much, heated oceans in some places. Well, that increases our ocean temperature from an average today of about 39 degrees Fahrenheit to a global average of 86 degrees Fahrenheit during the year-long flood. But in some places, localized areas, it's going to be much hotter, giving perhaps the right mechanisms for this Dolomite to form. And the fact that we find Dolomite not only in certain regions, but we find Dolomite throughout even sandstone layers.
Oh, really?
There are sandstones that many geologists believe were deposited by wind-blown sand, alien environments that contain Dolomite, seawater. So wait a minute, was it deposited by water or was it deposited by wind?
Yeah, that's an inconsistency.
And it's a big mystery. And even in creation geology, we're still trying to piece together the exact mechanisms by which Dolomite is formed. But it's such a big mystery to everyday processes of geology that they actually call it the Dolomite problem.
Wow, that's interesting, especially thinking about if they're going to go with the rising and falling oceans, what's the mechanism causing that over and over?
Right. If oceans are, coming across the continents up to 17 different times, millions of years sitting on top of them, and then, washing back off the continents for millions of years, dry and solid rock, then that process back and forth, there's no known mechanism yet by which that can form, because you either have to completely raise the oceans or drop the landscape, or maybe a combination of the two. And it's still a mystery. Even tectonic processes don't explain multiple continents being covered with some of the same layers of water deposited sediment.
Yeah, absolutely. Well, and it seems like you would expect to see more erosion between the layers than what we do, right?
You'd expect there, between these periods of time, between the transgression of the waters moving onto the continents and then the recession phases, you've got millions of years of exposure of that landscape as the surface of the earth. And if the surface was exposed for millions of years, you should see millions of years of erosion on the surface of that landscape. Channels and valleys and gullies, all kinds of surface erosion, we don't typically find that very much. In most cases, in many cases, we find flat knife edge boundaries between these rock layers.
Oh man, that's awesome. Well, it looks like we're pretty close here to the crater, right?
We are. We're nearing Red Mountain Volcano. We're going to be seeing that here shortly, just up here on the left.
All right, awesome. Well, we'll catch you guys later.